So hello everybody, I'm Marin Tudoroiu. I'm from ESRIN, so the Center for Earth Observations in Frascati, and I'm part of the Mission Management and Product Quality Division, where together with my colleagues from the division, we are responsible for the mission management of ESA Earth observation missions, but not only. And on the other hand, on product quality for the missions that are in operations. I am the Flex Data Quality Manager, and in very few words, my main role is to ensure that you, the users, will receive the best quality data from the Flex mission when the satellite will be in orbit. This means that prior to the launch, I have to prepare some activities. I have to ensure that the operational processors that convert the signal coming from the satellite into the nice maps that you will download are developed together with the tools that we need to monitor the instrument performance on one hand and the data quality or the calibration validation activities. After the launch, I will have to make sure that anomalies that can impact the data quality are kept under a strict radar, and together with the mission manager, we take the needed measures to keep the data quality in line with the mission requirements. So today I will talk about one of the future plans for the Flex mission, which is the collaborative platform, a tool that will be open to all the users. I will talk a bit about the framework in which will be developed. We'll give you some background on why we think such tool is very important for the Flex mission. And let's say I will close up with a sort of working examples from the mission analysis and algorithm platform created for the Earth Explorer 7 Biomass in collaboration with NASA, just to give you a teaser of what you can expect from the Flex collaborative platform. I structured my presentation into 5 sections, as you can see on the screen. First, I will make a short introduction where I will give a bit of the context on what my group, so my section in ESRIN is doing, and a bit of background on the Flex mission for those of you who have missed the very nice talk that Matthias Drusch gave in the first webinar. I will give you a bit the framework where an overview of the framework where the collaborative platform will be developed, what features you can expect from the Flex collaborative platform, and as I was talking before, I will give you some examples from the Biomass map. As I was saying in the beginning, in the division, we are responsible for the satellite mission management and overall product quality. If we go one hierarchic level in this ESA structure, at section level, I am part of the section called Sensor Performance Products and Algorithms. And the main activities are centered around ensuring that the users are provided with the best possible product quality in line with the mission requirement documents. And during the exploitation phase, the main activities are processor algorithms, maintenance and evolution, performance assessment and on-demand quality control, system calibration, product validation, and we have to ensure the end-to-end sensor data set performance. So this is what me and my colleagues are doing for different satellite missions. And if we put these activities together, we can resume everything to 3 main pillars. So algorithm development and evolution, CalVal, routine quality control, and performance monitoring. Often, well, we don't do this job by ourselves. We have the support from industry and from academia, and we try to gather the best expertise in the fields of every missions in groups that will work in big contracts like that we entitled Data Innovation Science Cluster DISC for the Earth Explorer missions and Mission Performance Cluster MPC for the Copernicus mission. So let's go to Flex. What is Flex? Flex is the Earth Explorer mission, the 8th ESA's Earth Explorer mission, and will be deployed in 2026, having as a payload a high-resolution imaging spectrometer designed to accurately measure the fluorescent signal emitted by the plants to assess their functioning, health, and stress. I'm sure most of you know about the Flex mission, but just a quick reminder on the main specification and main characteristics. It's the ESA's. It was promoted as a ESA's photosynthesis mission and will provide global measurements of vegetation fluorescence that will help us to quantify photosynthetic activity and plant stress by mapping vegetation fluorescence and to advance our understanding of the photosynthetic machinery. It is a mission that will fly in tandem with Sentinel-3 and will provide maps of on-ground spatial resolution of 300 by 300 meters and the swipe width of 150 kilometers. What has to be noted here that this is the first tandem mission between two different satellite missions. For Sentinel-3, for instance, we had a tandem phase where you cross-calibrate the two units of the same satellite mission, but it's the first time that we will have two different satellites flying in tandem. And Flex needs this auxiliary information from Sentinel-3 for the retrieval of fluorescence. So we need the data from the Olchi and the Celestial on the atmospheric state and land surface characterization to retrieve fluorescence. Going to the main specification, it is designed to last 3.5 years after a commissioning phase of 3 months. It will fly in tandem with Sentinel-3, as I was mentioning before, 100 kilometers ahead, which is translated in maximum 15 seconds ahead of Sentinel-3. It will fly in similar orbit as Sentinel-3, as unsynchronous, at the same altitude, 814 kilometers. It will have a repeat cycle of 27 days. It will acquire data at the local time 10 a.m. and the flight operation will be handled by the Center of Operations in Darmstadt via the ground station Kiruna. The expected launch, as I mentioned before, is probably mid-26. It is a relatively small satellite that has a total mass of about 500 kilograms. The payload is the fluorescence image spectrometer, FLORIS, which is a high-resolution imaging spectrometer that will acquire data over land, inland waters, and coastal areas in the 500 to 700 nanometer spectral range, so the range where photosynthesis happens, and will have a sampling of 0.1 nanometer in the oxygen absorption bands. And I added this image here, which I'm sure you all know very well, just to show that we need this very fine resolution to be sure that we can retrieve these very narrow fluorescence peaks. And for the rest of the spectrum, we'll have 2 nanometers in the chlorophyll absorption band and the photochemical reflectance index band, and then between 0.5 to 0.65 nanometers in the rest of the spectral range. And since I started to tell you about the disk, I will just give you an overview of what DISC is about. So the Data Innovation Science Cluster is the framework in which the collaborative platform will be built. But the DISC is much more than that, of course, as you could guess from the first slides. And it will be the central element in ESA's data quality framework for the FLEX mission. And it will comprise a cluster of international experts in the field of fluorescence, but not only, to ensure that the data quality of the FLEX products is the best possible. On the other hand, is the central element in product evolution cycle, combining ground processor evolution with sensor performance monitoring and CalVal and other activities. It will have specific tasks on algorithm development and evolution of the operational processors. It will have tasks related to product data quality monitoring, develop new prototype and processor and generation of new data sets for the user community, but also tasks on CalVal. And put in a very simple sentence, the main goal is to assure that the users are provided with the best possible product quality in line with the mission requirements. If we go more into detail to understand how this goal is ensured, well, it's ensured by accomplishing a numerous amount of tasks. And here, in the case of the FLEX, we split this activity into 4 phases, 2 of them before the launch, development and preparation, and 2 of them after the launch. On the other hand, these tasks can be split into 3 main categories, as you can see from the gray boxes: instrument calibration and performance monitoring, scientific process or facility, and CalVal. And in addition, we will also try to address secondary objectives that are related to development of new experimental products. In the development phase, of course, we have to ensure what I was saying in my brief presentation is that all the tools and more importantly, the processors that convert the raw data to the maps, nice maps of the Flex products will be developed timely. And then in the preparation phase, we have to ensure that all these tools and processors are integrated into our ground segment. They are tested and they perform in optimal conditions, and we are ready for the launch. So ready to acquire real data and to process it to give you the products that you want. In the commissioning phase, of course, we will have the first taste on real data. So we will have the commissioning phase that will be 3 months after the launch. We'll have to ensure that first we check that all the end-to-end processing chain is working. So the raw data coming from the satellite and acquired by the ground stations are converted into final products from the Flex mission. And secondly, we can do a preliminary validation of the processors and all the tools. In operations, in addition to all the tasks that we will perform in the short time of the commissioning period, we have to routinely monitor the instrument performance and change calibration coefficients if necessary. We will need to evolve the processors to be sure that we maintain a high quality level of the products, but also to develop new products or provide user support. But maybe one of the important things is also related to the calibration validation of the products. So this is how we plan to ensure that the products that you receive are in line with what you expect after looking at the mission requirements. And one tool that we have in mind to develop, so the topic of the discussion today is the Flex collaborative platform. That is a tool made for the users at the interface with the disk. And you may ask us what is the motivation to build such a platform. Here, there are maybe two aspects to consider. One is the perspectives of the users and the service that are provided to the users. From the user's perspective, and I'm sure some of you are finding yourselves in this category, you may ask yourself, where do I find in situ data to validate my own algorithms? A good idea to improve the official data set. I want to compute a lot, but I don't have the necessary facilities or I don't have enough storage capacity. And if we think about the services to EO mission, we know that often they are pretty scattered. You can have the data access on one page, you can have the forums on another page, or you can have the tools even on a different page. So the collaborative platform is thought exactly to address these issues. It is a virtual, open and collaborative environment that will allow researchers to easily discover, process, visualize, and analyze large volumes of data. It will provide tools to enable comparison, analysis, data and evaluation, and data generation. It provides development environment tools to support tools and collocated data and processing resources. And last but not least, we'll address intellectual property and sharing issues, which we all know that this becomes more and more important with the GDPR rules. One of the main functionalities of the collaborative platform, as I was mentioning, will be the openness of the algorithm development. So let's call it algorithm development philosophy. One of the main functionalities is to implement this philosophy. In a normal development of an operational processor, you have an algorithm initial definition, then a first implementation. But what the collaborative platform brings the users into this process. So the users can modify the code, they can generate a new corresponding data set, they can then validate it with the data, the calibration, the validation data available on the collaborative platform, and they can verify and send further for approval to ESA of a new data set. And this loop can continue on and on for whatever product you can imagine. So openness of the algorithm development implementation. So in a nutshell, it will allow to easier evolve the algorithm development and arrive to faster and stable algorithms for R&D missions, and will allow people outside the core science team to contribute to the product improvement cycle. And I'm not saying only about maybe people will bring only improvement to the computational speed, not necessarily to the scientific outcome, but any improvement will be facilitating, it will be much faster. And of course, the concept of open science will adapt it to this type of missions. But such functionality, of course, it cannot exist if you don't give certain features and tools to the collaborative platform. And the features that you can expect from the collaborative platform will include data access, advanced visualization capabilities, a web-based development and execution and tools, and a user management environment. And now if you think what data you will have access to related to the Flex mission, well, that is, of course, everything that you would need for Calval activities. You will have access to, maybe one thing to highlight here is that the collaborative platform will be the interface that will allow you to have access to the data. So the data will be stored elsewhere, but via the collaborative platform, you will be able to access it and import it and perform visualization or other operations. And of course, you'll have access to all the Flex data, level 1B, C, and level 2, and whatever other products will become available in the future. You will have access to ground data like the Radcal network, the Aeronet, the Fluxbox network, or other network that users might think can be useful. You can have access to airborne campaign data, access to other satellites data that can be useful for the Flex mission. You will have access to models like Scope. And last but not least, you will have access to file system emulation. One of the main tools that, of course, we want to implement on the collaborative platform is a Calval tool that would be an open source tool that will allow, on one hand, the disk users to use the ESA validation data and the Flex products to validate the products. But on a different point of view, you can imagine a user wants to change a piece of code, like somebody from exterior to change a piece of code and to validate his own product against validation data that can be provided by ESA or by a user itself, if he's trusting that his ground truth is at a high level of quality. Or can create a custom product that doesn't exist among the core products and use the same tool to perform the validation of his product. And this can be possible only if we leave it very open and very flexible. So it will be in the shape of a script that you can modify if you need, or just click and run to obtain all the information that you might want. Up to now, I talked mostly theoretically because we still didn't start the development of the Flex collaborative platform, but this will start in the next months. But now I will show you some examples from the pilot of the Biomass map built in collaboration with NASA. And they are more advanced than us, of course, because of several programmatic aspects. The mission development started earlier, so they are quite advanced, but this is only an advantage for Flex because a lot of the elements that have been produced for the map of Biomass can be reutilized for the Flex collaborative platform. So I will show a few examples on visualization capabilities, mainly on data ingestion, and a bit on working environment and validation. For Biomass, an interesting data set is the one from Sentinel-1. And here you can see an adding Sentinel-1 data set, which is not on the collaborative platform. So it's uploaded from somewhere else. You can upload the map, the data, you can zoom in. You can, of course, change the color scale and eliminate the outliers to be sure that you look only at the signal that you want to see. Then you can zoom in again, and you can see all the level of details that you expect to see from the respective satellite map. And then, of course, here is just a subset, but you can also select a different date, and then you can zoom again, and you can see exactly where the new map is located. And one feature that will be in the future is that you'll also be able to do some plots and basic statistics on the fly on this image. Remaining to data visualization, here you can import also airborne data. I will show you how you can import campaign data. In this case, for Biomass, they had a campaign in Gabon a long time ago. And here you can select the data set, you can select the layer that you want to show. Just as before for the satellite data, you can again arrange the scale to be sure that you see only the signal that you want to see. Here we have another example importing ground dataset, which is external from the map. So as I was saying, the collaborative platform, you have to think in case it creates a bit of confusion, the map and the collaborative platform are the same. So it's just different names for the same type of platforms. And in this case, you have insertion of a ground truth network, and you see the plots that they use to measure biomass. You have the main characteristics of the site, like average height, average diameter. You have pictures of the site, and here you can imagine for Flex it will be the case of a site with a Flux box, and you will have all the information that you can have about that site. And of course, you can zoom in and zoom out as you like. And as you can see, the sites are distributed in different areas, not only in one specific site. Speaking about the working environment, here I'm showing you. So here you have access to the data that was shown previously to visualize. You can really have access to the data that it was used before. You can have access to the data, you can import it, you can perform operations on it. Like here you see exactly all the images that were collected in the campaign that they had in Africa. And every data set can be uploaded in a working environment, in a Python or a Jupyter notebook using some Python scripts, and you can do any operations that you might want. And last but not least, I was talking a while ago about the validation tool. This is a basic example of a validation tool. In the same environment, you can have this tool, and it will be like an open tool script that you can either just click and run, but it's also open, so you can modify it as you want. In this basic example, it's about above ground biomass. So you can, using this script, you can import the input data, so a synthetic biomass map. You can define the ROIs, the region of interest. You can then display the product, so the map that you import, with a proper color scale. And for each region of interest, you can compute so very basic statistics like the mean value, the minimum value, the maximum value, and the standard deviation. And for this very basic example, for above ground biomass validation, the mean value of the region of interest was compared to the ground truth. And here you compute some higher level statistics like correlations, and you can plot the result. And all just with a one click. And of course, this example, maybe the results are not the best, but this is just to exemplify you what you could do. And in the case of Flex, you can imagine that a certain user wants to change a part of the processor. Let's say try a different model of atmospheric correction. You could apply the change to the processor, run it, obtain your image and then validate it against the validation data exactly in a similar way as this tool was showing. So I hope that by now I convinced you that it's very important to have such a collaborative platform, especially for R&D missions. And I can add a few more arguments. So we expect that the flex data size will be quite big. So we are talking about gigabytes for a few minutes of data. And we think it's better to bring the user to the data than vice versa. The development and validation of new or modified algorithms can be reasonable, done much faster in a collaborative environment. The execution of regional algorithms would not put any pressure on a user to commit resources, but can be directly done on the collaborative platform and can also be, for instance, set up to run automatically and every day to have a regional product. Execution of new or modified algorithms that was already validated on a global scale. I think this is a big advantage because a user must not download the entire data sets globally, but can process it directly on the collaborative platform. And what I can say is that for sure, a collaborative platform Flex will be developed and implemented in the ground segment before the launch. And I think we are on a good track with this. We will start the activity in a few months. And I think we have a very good and very motivated team. And I hope that in 1 year time or something like that, I can come and show you real working examples from the Flex collaborative platform, not from another mission. And this brings me to my final slide of the talk, the conclusions. What to say about the collaborative platform more? It will make the connection between data, algorithm, software, and results. Brings together data from various spaceborne missions, but not only, also from campaigns like ground data and airborne data. The open source approach for operational processor will make it much easier to reproduce results and build from existing work. And what you have to bear in mind is that the concept of collaborative platforms is becoming the baseline for all the future ESA missions, not only for the Earth Explorer, but also for the Copernicus mission. And with this, I thank you for your attention, and I'm, of course, open to questions.